Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 3, Lesson 10. Let's get started. All right, in our opening exercise, we have a statement. The amount of money I have in my pocket is less than $5 but greater than $4. And we need one possible value for the amount of money in my pocket. Well, it's less than 5 but greater than 4. So anything between 4 and 5. So I'm just going to choose $4.50. That's right in the middle. Okay, and then we're going to write an inequality statement comparing the possible value of money in my pocket to $4. Well, I'm going to say the amount of money in my pocket, which is $4.50, is bigger or greater than $4. So there's an inequality statement. $4.50 is greater than $4. And just a note about these inequality signs before we go any further. As you read the inequality from left to right, the first part of the sign that you get to is the big part. So this sign is going to mean greater than as I read from left to right. But if I turn that around, I can also read from right to left. If I read from right to left, now the first part of the sign I get to is the small part. So now the same symbol is going to mean less than. So if I read from right to left, this is going to say $4 is less than $4.50. So very important that you understand when you read an inequality, the direction you read it changes its meaning. And that'll become evident when we get variables in here, and it'll be a lot easier to understand what X is if you read from the variable and then interpret this sign depending on how you read it. But for now, we have $4.50 is greater than 4, or $4 is less than $4.50. And then for part C, write an inequality statement comparing the possible value of money in my pocket to $5. Well, this time I'm going to say $4.50 is less than $5. But again, I can turn around and read in the other direction, and it'll say $5 is greater than, I get to the big part first, $5 is greater than $4.50. So either way you read it, it is true. Okay? All right, so let's take our answer from the opening exercise. We had $4.50. We'll use that again. And we're going to graph the points associated with 4 and 5 on the number line. So I'll put 4 here on the left side, I'll put 5 on the right side, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So $4.50 will be right here in the middle. So I have $4 on the left side, $4.50 is in the middle, and $5 on the right side. Okay, explain in words how the location of the three numbers on the number line supports the inequality statements you wrote in the opening exercise. Well, I said $4 is less than $4.50, and then I said $4.50 is less than $5. So I've got those two inequalities. And then lastly, we're just going to write one inequality statement that shows the relationship among all three. And this is a compound inequality where I'm going to say 4 is less than 450, which is less than 5. And now they're all related. So I could say, well, since 4 is less than 450, I can say 4 is also less than 5. And that's true. Or I could turn around and read it in the other direction, and I would say 5 is greater than 450, or I could say 5 is greater than 4. So either way, I've got all of the relationships between the three numbers. That's a compound inequality, and we'll be using those in this lesson as well. All right. Example 1, write one inequality statement to show the relationship among the following shoe sizes. I have 10.5, 8, and 9. Well, I can do this in a few different ways, but let's go least to greatest first. I could say 8 is less than 9, which is less than 10.5. Or I could write from greatest to least, and greatest to least I would have 10 1/2 is greater than 9, which is greater than 8. So I've done both from least to greatest and greatest to least, but really, if you think about it, I did that all with my first inequality statement. It just depends on how you read it. If I read from left to right, I have least to greatest. 8 is less than 9, which is less than 10 1/2. Or if I read from right to left, I have my greatest to least. 10 1/2 is greater than 9. Remember the sign, the first part of the sign I get to, I'm reading this way. That means greater than now, so 10 1/2 is greater than 9, which is greater than 8. So I really did it in my first expression, but in order to change the order, we can write greatest to least and get this second one. Okay, and we're just ordering, just like we did before, but now we're using inequality symbols. All right, example 2. Mary is comparing the rainfall totals for May, June, and July. The data is reflected in the table below. Fill in the blanks below to create inequality statements that compare the changes in total rainfall for each month, which is the furthest to the right. That's this one. Okay, so we're going to write an inequality statement from least to greatest. So I see a negative 1.4. That's going to be smaller than 0.3, which is smaller than 0.5. So there's least to greatest. And if I turn around and go greatest to least, put that down here, that's 0.5 is greater than 0.3, which is greater than a negative 1.4. Okay, so we've got two different inequality statements, least to greatest and greatest to least. Okay, exercise 5. Mark's favorite football team lost yards on 2 back-to-back plays. They lost 3 yards on the first play. That's going to be given by a negative 3. And they lost 1 yard on the second play. That's given by a negative 1. Write an inequality statement using the integers to compare the forward progress made on each play. Well, 2 possibilities here. I'm going to say negative 3 is less than negative 1, or I could say negative 1 is greater than negative 3. Okay, so I've got 2 inequality statements. Again, if I read right to left, it says negative 1 is greater than negative 3. So either one will work, and they're both correct. All right, number 6, Sierra had to pay the school for 2 textbooks that she lost. One textbook cost $55, that's a negative 55. And the other cost $75, that would be a negative 75. Her mother wrote 2 separate checks for each expense. Write 2 integers that represent the change to her mother's checking account balance. Then write an inequality statement that shows the relationship between these 2 numbers. Well, again, I've got my integers already, so now I just need an inequality statement. I know that negative 75 is the smallest, so negative 75 is less than negative 55. Or I could say that negative 55 is greater than negative 75. There are your 2 possibilities. All right, that's 6. Exercise 7. Jason ordered the numbers negative 70, negative 18, and negative 18.5 from least to greatest by writing the following statement. Is he correct? Well, Jason is saying that negative 18 is the smallest number, and if we thought about them on a number line, just sketched it out, if that's a 0, the first number I would get to in the negatives would be a negative 18. Maybe in here. A negative 18.5 would be next, and then the negative 70 would be all the way down here. So really, my smallest number is a negative 70. So I should say negative 70 is less than negative 18.5, which is less than negative 18. That should be my inequality statement, and it looks like he wrote it from greatest to least. So this is not a true statement, and you would have to either change the order or change the signs. If I just wanted to change the signs for Jason to help him out, I would say negative 18 is greater than negative 18.5, which is greater than negative 70. So either change the signs or change the order. Okay, and then our last exercise for today, write a real-world situation that's represented by the following inequality. Negative 19 is less than 40, and explain the position of the numbers on a number line. Well, my story could be lots of possible things. It could be an amount of money that I pay, and then an amount of money that I get. Maybe I have to pay for a new calculator that costs me $19, and maybe my grandparents give me $40 for my birthday. That could be something, but the real world situation could be a lot of different things, as long as the negative 19 equates to something that is lost, and the positive 40 is something that's gained. And so let's look on a number line at where these would be. And we would have a 0 here in the middle. And let's say we put, let's go 20 and 40 so we can see these. Well, 40 obviously would be all the way to the right. And then if I had a negative 20 and a negative 40 over here, I could find that the negative 19 is going to be just a little bit before I get to negative 20. So negative 19 would be here. And we can clearly see that negative 19 is less than 40 because left is less. And we remember that from our previous lessons. All right, that is lesson 10. I hope that helps. See you again next time.